Hello everyone, my name is Sunil Sharma. The topic of today is refrigeration. The table of content for today's topic is Introduction, Unit of Refrigeration, Performance of a Refrigerator, Applications of Refrigeration, Refrigerants, Properties of Refrigerants, Methods of Refrigeration, where we will discuss two methods: vapor compression refrigeration system, vapor absorption refrigeration system, difference between these two. What is refrigeration? It is the branch of engineering science that deals with transfer of heat from a low temperature region to a high temperature region. In order to maintain a region at a low temperature, we use refrigeration. The system used to accomplish the process of refrigeration is known as refrigeration system, and the place is to be cooled is known as the refrigerator space. What is the unit of refrigeration? This is known as tons of refrigeration. It is abbreviated as TR. A ton of refrigeration is defined as the amount of refrigeration effect produced by the uniform melting of 1 ton of ice from and at 0 degrees Celsius in 24 hours. The one thing that should be taken care is the 1 ton here is not is equal to 1000 kilogram, while it is equal to 907.18 kilogram. This is known as US ton or short ton. The value of 1 TR is equal to 210 kilojoule per minute or 3.51 kilowatt. If we want to measure the refrigerator's performance, first we need to think how it works. So this is the space which is to be cooled, which is at TL, lower temperature. The heat will be removed from this with the help of a refrigerator. Refrigerator will work because of the heat or energy input to it. Due to the energy input, we will find some work input to the system, and the system is refrigerator. The heat absorbed by the refrigerator will be released to the environment. The environment is having more temperature than the required cooling space. Okay, so in this case, the coefficient of performance, which is the performance parameter here, COP, is denoted by desired output upon required input. So desired output is the lower temperature's heat rejection, QL, while the required input is WNet, this, which may be represented in form of this formula. Refrigerating effect is the amount of heat energy removed per unit time from the space to be cooled by the refrigeration process. Now let's see about the applications of refrigeration. There are various applications of refrigeration as preservation and transportation of food. It may be cooked food or the raw food. Used for air conditioning purposes, preserving life-saving drugs, vaccines and other medicated solutions, etc. Use for making ice products, chocolates, etc. Use for the efficient operation of computer servers, special machining and other workstations. As these may be seen in these pictures, these for ice plants, air conditioners, cold storages, domestic or deep refrigerators used in industries and commercially also. Now, what are refrigerants? These are working fluid used in refrigerators. These are majorly of two types, primary and secondary. Primary refrigerants directly take part in refrigeration system as Freon 1,2, while secondary refrigerants are first cooled by primary refrigerants and then cool the system. These are like brines, sodium chloride, calcium chloride, ethylene glycol, propylene glycol. Now we come to the properties of refrigerant. This is a very important topic because the properties not only covers physical or chemical properties while also cover the environmental and safety properties. So first we come to ozone depletion potential, ODP. According to Montreal Protocol, the ODP of any refrigerant should be equal to 0. Global warming potential, GWP. The GWP value of any refrigerant should be as minimum as possible. The refrigerant should be non-flammable, non-explosive, non-toxic, and chemically stable. Latent heat of refrigerant should be very high. Action with the materials should not be there, means it should be non-corrosive to metals. Boiling points and freezing point should be less. There are basically two methods of refrigeration: vapor compression refrigeration system and vapor absorption refrigeration system. This is known as VCRS, while this is known as VARS. First we go to VCRS. So these are the four components: evaporator, compressor, condenser, and expansion valve. And this schematic may also be understood through this chart. Okay, so first we discuss this schematic. So what it says, the refrigerant inside the tubes is available in the evaporator. It absorbs the heat from the cooled space or the space which is to be cooled and converts into vapor. These vapors goes to compressor. Here in compressor, these vapors converts to very high pressure and high temperature having compressors. High temperature and high pressure vapors means superheated vapors. Then it goes to condenser, where it releases heat to the environment, and then it moves to expansion valve, where it releases temperature and pressure both, and the output of the expansion valve is at very low pressure and at low temperature. Similarly, it may be seen with the help of this TS diagram also. On the vertical scale there is temperature, on the horizontal scale there is entropy. The 1 to 2 is the compressor, while it consumes energy, work is done on the system, and at point 2 the highest pressure as well as highest temperature is there, and this is in superheated state. Then it releases sensible heat, and then latent heat comes to point number 3, where 3 to 4 is a throttling process and 4 to 1 is again a heat exchanger process. So 4 to 1 and 2 to 3, this condenser and evaporator, these two are heat exchangers, exchanges heat with the environment. On the similar principle, we have just studied the domestic refrigerator works. How it works, this is the domestic refrigerator. The upper part normally is for refrigerating box, where all the heat of the refrigerator is absorbed and the refrigerant inside the refrigerator tubes is evaporated. This evaporated refrigerant moves to the compressor and it converts to high pressure and high temperature vapors of refrigerant. Then it is cooled with the help of environmental air, and then it moves to expansion valve. Normally in case of domestic refrigerators, the capillary tubes are used as the expansion valve, and the cycle goes on. So this is vapor absorption refrigeration system, in which the three components other than the compressor are same as condenser, expansion valve and evaporator, while the compressor is replaced by this whole bigger arrangement. So what is this arrangement? First we look at this. There are four components. First is absorber, then this is solution pump, then it is generator, and this is pressure reducing valve. So how it works? The vapor from the evaporator goes to the absorber, where there is already availability of solvent in the absorber there. That solvent mixes or absorbs the solute or the refrigerant vapor and makes a solution. The solution is pumped through a solution pump. Then it goes to generator. In generator, we heat the system with the help of steam or waste heat or heating coils or by some other method, and due to heating, the vapor refrigerant vapor again separates from the solvent and moves to condenser, while the solvent again moves back to the pressure reducing valve and then to the absorber. So this system for the solvent, so this is the cycle for solvent, while this is the cycle for the refrigerant. Okay, this system is not using compressor, so it gives comparatively lesser COP. It consumes less energy. It is very good for the bulky systems, but not for the smaller domestic systems. So the differences between VCRS and VARS. In case of vapor compression system, the main part is compressor, while here is generator, absorber, solution pump instead of compressor. Here the system is noisy because compressor makes noise. Okay, but in case of vapor absorption system, all the systems are non-moving, so this is quite in operation. While in case of vapor compression system, has no moving parts. Has I'm sorry, it has moving parts, so there is a possibility of wear and tear. Okay, so maintenance is also required here. While in case of vapor absorption system, it has no moving parts and no possibility of wear and tear or sticking. In case of VCRS, electrical energy is supplied, while in case of vapor absorption efficient system, energy input is mainly heat. It may be done with the help of waste heat or hot steam or some other method. Here COP is very high, while here COP is very low. System is very compact, while system is bulky, not compact. This is all about the refrigeration. Thank you very much.